Okay, so today we are going to start into lesson 2 about function combinations and compositions. The first few things are just operations with functions. So you can see here if we are doing f plus g of x, that's the same as adding the functions together separately. Naturally, subtraction works the same as addition. Fg stands for f times g, so you want to take function f times function g, and then dividing stands for f divided by g of x, noting that g of x cannot equal 0 because then we would be dividing by 0. Domain for these values are all x values that are common to both. So in other words, it's the numbers that are in the domain of g that are also in the domain of f. The composition of functions is a little bit different. A composition of functions is this word that a lot of you will read as fog, that stands for f composed of g of x, or in Euler's notation we write it as f of g of x. The domain for a composition of functions is a set of all x that are in the domain of g such that g of x is in the domain of f. So in other words, it's the domain of g of x such that the range of g of x is inside of your domain of f. So that gets a little bit more complicated there. So let's look at the first problem here. Given the f of x is equal to x squared and g of x is equal to 1 minus x, find f plus g of x. So f plus g of x, we would simply add those two together. So we would have x squared plus 1 minus x, which we should hopefully write as x squared minus x plus 1. And we're done with that problem. It says find f minus g of x. So we just subtract them. X squared minus 1 minus x. Remember here we don't want to make a common algebra 1 mistake. Whoops, it didn't pick up the green. We want to distribute that negative sign like there's a negative 1 there, so we would have x squared plus x minus 1. Third one is f times g of x. So I'd take x squared times 1 minus x, and we would end up with x squared minus x cubed. And then the last one, f over g of x. We would want to take x squared divided by 1 minus x. And there's no simplifying that we can do to that problem, so we're just done with it. So the next part that we don't want to forget about, so go back and reread our directions, and it says, and state the domain. So here, my domain is all real numbers. I am not dividing, I don't have square roots, so that's negative infinity to positive infinity. Same thing on the second problem, negative infinity to positive infinity. Same thing on the third one, negative infinity to positive infinity. Remember this in Algebra 2 we just referred to as all real numbers. It's on the last one where we've got x squared divided by 1 minus x that I have to worry about dividing by 0, so that's where I would set the bottom not equal to 0, and I would get x's not equal to 1. So we would write that as negative infinity to 1 union 1 to infinity. And that's our domain for that problem. Problem 2. Those graphics are terrible. I super apologize about that. Find fg of 2. So I want to find f of 2 times g of 2. So f of 2, I'm going to take 2 times 2 squared, so that's 8. Minus 3 times 2 is 6, plus 6. And then I want to multiply that by plugging 2 into my g equation. So 5 times 2 is 10, minus 4. So we end up with taking 8 times 6 is 48. So that's f times g of 2, or fg of 2. Find fg of x. So this is where we want to take f of x times g of x. So my f of x is 2x squared minus 3x plus 6 times my g of x, which is 5x minus 4. And now I just want to do a massive FOIL job on this. So I'm going to distribute the 2x squared inside of here. So I end up with 10x cubed minus 8x squared. Now I'm going to distribute the negative 3x. Negative 3x times 5x is negative 15x squared. Negative 3x times negative 4 is plus 12x. I just write it this way just so we line up our like terms. Now we distribute the 6. I get positive 30x and minus 24. Simplifying gives me 10x cubed minus 23x squared plus 42x minus 24. And that's fg of x. Letter C wants us to find g divided by f of x. So we would take 5x minus 4 and divide that by 2x squared minus 3x plus 6. We could factor this, but nothing's going to factor out to give me a 5x minus 4 because I can't get 2x squared. So this would be my final answer on that problem. Letter D asks us to find f minus g of x. So I'd take 2x squared minus 3x plus 6 and subtract 5x minus 4. So we would end up with 2x squared. Negative 3x minus 5x is negative 8x. And then 6 minus a negative 4 is 6 plus 4, which is 10. And then letter E, f plus k of x. So I'd take 2x squared minus 3x plus 6 and add 1 over 2x minus x. So for this one, we would, because we're in pre-calc, we can't leave it in this ugly form. I could rewrite it as 2x squared minus 4x plus 6 plus 1 over 2x. But I really want to get a common denominator on everything. So I need to multiply each one of these. Whoops, it did not take my new color. Sorry about that. So each one of these is really over 1, and I'm going to multiply everything by 2x over 2x. So each one of these I'm going to multiply by 2x over 2x. That way I have a common denominator on all 4 parts. So I would end up with 4x cubed minus 8x squared plus 12x. And now since I have a common denominator of 2x, I can put the plus 1 from right here. And all of it will be over 2x. And that would be my final answer for part E. Number 3, find RW of x. So I want to take R of x and multiply it by W of x. So we end up with 6x cubed minus 10x squared plus 14x. And now I need to distribute the negative 7, so that's minus 21x squared plus 35x minus 49. So then combining like terms, I would end up with 6x cubed minus 31x squared plus 49x minus 49. And my domain, since I don't have division or square roots happening, my domain is simply negative infinity to positive infinity. Letter B wants me to take R minus W. So 2x minus 7 minus 3x squared minus 5x plus 7. Remembering here, distribute the negative 1 inside of your parentheses. We'd end up with negative 3x squared. 2x minus a negative is plus a positive 5x is 7x. And negative 7 minus a positive 7 is minus 14. Likewise, I'd have negative infinity to positive infinity for my domain. And then letter C, we want to take C divided by W. So that's the square root of 3x minus 1 over 3x squared minus 5x plus 7. So this is where I have to worry about both of my rules. So I want to set 3x minus 1 greater than or equal to 0 and solve. So I would add 1 and divide by 3, and I get x is greater than or equal to 1/3. So out here to the side, I'm going to draw a number line. And right now my domain, as determined by C, is numbers greater than or equal to 1/3. So that would be a closed dot on 1/3 and an arrow going to the right. Or I'm sorry, that was from W. No, it wasn't. It was from C. Sorry. Now I also want to worry about my bottom because that's where I could divide by 0. So I set 3x squared minus 5x plus 7 not equal to 0, and I need to solve that. So we can do this by bottoms up. So I multiply this together and I get 21. The factors of 21 that add up to be negative 5. I don't believe there are any. So bottoms up doesn't work. So let's try quadratic formula. X equals negative b plus or minus the square root b squared minus 4 times a times c all over 2a. Four times 3 is 12. 12 times 7 is 90. I'm sorry, 12 times 7 is 84. So 25 minus 84 is a negative number. That's negative 59, which this is imaginary. What that tells me is the bottom, the denominator, can never be equal to 0. So in other words, I will never be dividing by 0 for any value of x. So my domain is just determined on this problem by the numerator. So it's 1/3 to infinity. Find f of g of 6. So this is where we get into a composition of functions. So I'm going to start out from the middle. I'm going to find g of 6. So that's 2 times 6 plus 3, which is 15. So now that I know that g of 6 is equal to 15, I'm going to come in here to this g of 6, and I'm going to replace it with 15. So that leaves me with f of 15. So that I'd take 7 times 15 minus 9. So that is 105 minus 9 is 96 as my final answer. Letter B asks us to find g of f of 2. So I work from the inside first. I find f of 2. So that's 7 times 2 minus 9. So 14 minus 9 is 5. Now likewise, I have f of 2 equals 5. I have an f of 2 right here, so I'm going to use substitution to find g of 5. So that's 2 times 5 plus 3, which is 13. That's my final answer. Try the next one on your own. Please pause the video. Okay, so on this one you should have found h of negative 5 to be 2 times negative 5 squared minus 4. Remember, a negative 5 squared is positive 25, times 2 is 50, 50 minus 4 is 46. So now I'm going to replace h of negative 5 with 46. So that'll leave me with g of 46. So g of 46, I'd take 2 times 46 plus 3, which is 95. All right, the last one looks a whole lot uglier. So we just start off in the very inside. So we find g of negative 2. G of negative 2 is 2 times negative 2 plus 3. So that's negative 4 plus 3 is negative 1. So now I'm going to plug that in for g of negative 2. So I now have f of h of negative 1. I just replaced that g of negative 2 with the negative 1. So now I'm going to go to my h equation, and I'm going to plug in negative 1. So 2 times negative 1 squared minus 4. So negative 1 squared is 1, times 2 is 2, minus 4 is negative 2. So now I'm going to replace my h of negative 1 with negative 2. So f of negative 2, I'm going to take 7 times negative 2 minus 9. So that's negative 14 minus 9 is negative 23. And that's my final answer for f of h of g of negative 2. Given f of x and g of x, find the following. So remember, the f composed of g of x is the same as saying f of g of x. They are the same statements. They are equivalent. So just like before, I want to work from my inside out. So I want to replace g of x with 4x squared plus 1, because that's what they tell me that g of x is equal to. So that would leave me with f of 4x squared plus 1. So now I take my f of x equation, and I'm going to replace every x with 4x squared plus 1. So it originally said 2 times x plus 5. I just replaced the x with 4x squared plus 1. Distribute here, and I get 8x squared plus 2, and then plus the 5 more would be plus 7. So that's f composed of g of x. Now let's do g of f of x. So I'm going to replace the f of x with 2x plus 5. So I'll have g of 2x plus 5, because that's what my equation up here said, that f of x is equal to 2x plus 5. Now I'm going to go in my g equation, which is 4x squared plus 1, but where there's an x, I'm going to replace it with 2x plus 5. So that's my 4x squared, and then I need to add 1 to the end. Remembering here that I need to take 2x plus 5 times 2x plus 5. So we would end up with 4x squared plus 20x plus 25. Distribute the 4, and we end up with 16x squared plus 80x plus 101 when I add that 1 to the very end. So that's g composed of f of x. Now it asks for f of g of negative 1/2. Well, I already wrote an equation for f of g of x here as 8x squared plus 7. So I can just plug into that shorter equation rather than going through the steps of plugging it into g and then into f. So I'll take 8 times negative 1/2 squared plus 7. Negative 1/2 squared is positive 1/4. 8 times 1/4 is 2, plus 7 is 9. So we just created a shortcut rule for finding f of g of any number. So find f of g of x. So I'm going to take my f function, which is the square root of x, and I'm going to replace x with x squared plus 4. So that is my answer for f of g of x. There's no simplifying I can do because x squared plus 4 is not factorable. There's no factors of 4 that add up to be 0. And then find the domain. So the domain, I want to take x squared plus 4 and set it greater than or equal to 0. So we would take x squared greater than or equal to negative 4. Any number squared is always going to be greater than or equal to a negative number, so my domain is negative infinity to positive infinity. Find two functions f and g such that f composed of g equals h of x, and they give us our h of x equation. So I'm going to start off with my inner function g of x, and I go, okay, what's inside most of this? And that would be 8 minus x. 8 minus x is underneath my cube root sign. And then my f function, what I want to plug 8 minus x into is the cube root of x over 5. So that way when I take f of g of x, I would plug this in for x, and I would have my original h of x equation again. Find f of x divided by g of x. So that's 2 over x minus 1 all over x squared minus 3 over 5. Remembering our rules for division, when we divide by a fraction, we multiply by the reciprocal. So I'm going to take the reciprocal of the bottom. So we end up with 10 over x minus 1 times x squared minus 3. There's no need to FOIL this back out. To FOIL that out, leave it in factored form. Find f composed of g of x. So f of g of x, so that's going to say to take f of x squared minus 3 over 5. So in my f function, I want to replace the x with x squared minus 3 over 5. Don't forget the minus 1 because it was x minus 1 here. So on bottom, I'm going to get a common denominator, so I'm going to change that minus 1 to minus 5 over 5. So I get 2 all over x squared minus 8 over 5. I got negative 8 because negative 3 minus 5 is negative 8. Now that's going to be 2 over 1 times by 5 over x squared minus 8. So we end up with 10 over x squared minus 8. And that's my function for f of g of x. Now let's do g of f of x. So that's going to take g of 2 over x minus 1. So I need to take 2 over x minus 1, square it, because it's x squared, minus 3 all over 5. Squaring that fraction would give me 4 over, and I need to take x minus 1 times x minus 1. So that's x squared minus 2x plus 1. So now I need to put this over top of 1 and multiply by x squared minus 2x plus 1 over x squared minus 2x plus 1. So I'm going to distribute here inside, and I would end up with, I'm going to write down here on the left, So negative 3x squared plus 6x, and then negative 3 times 1 is negative 3, and then I'm going to go ahead and add that 4 onto it, gives me plus 1. All over x squared minus 2x plus 1, all over 5, because I still have that 5 down here. That 5 is really 5 over 1, so dividing by a fraction is multiplying by the reciprocal. So if we multiply by 1/5, I end up with negative 3x squared plus 6x plus 1 over, you can distribute it if you want, you could leave it out front if you want, that would be fine, 5x squared minus 10x plus 5. Find fg of x and its domain. So I want to take 2x squared minus 3x minus 9. I'm going to put that over 1 times by x minus 3 over 2x plus 3. Whoops. So we would end up foiling here, we get 2x cubed. This would be minus 6x squared minus 3x squared is minus 9x squared. This would give me plus 9x minus 9x is 0. And then negative 9 times negative 3 is positive 27. Now you could try and factor that out. That's fine. I'm not going to today. But our domain, we would set the bottom not equal to 0. And we get x is not equal to negative 3/2. So my domain is negative infinity to negative 3/2 union negative 3/2 to positive infinity. That's it for today. Please go grab your homework and complete it.